Question number 1. In a compound microscope, the focal length of two lenses are 1.5 centimeter and 6.25 centimeter. If an object is placed at 2 centimeter from objective and final image is formed at 25 centimeter. So in compound microscope, this is objective lens and this is eye lens. Focal length of objective lens is 1.5 centimeter and this is E is 6.25 centimeter. If an object is placed at 2 centimeter from objective, this is object and this distance is 2 centimeter, and final image is formed at 25 centimeter from eye lens. The distance between the two lenses. So this distance is equal to V naught plus UE. So first find V naught. So from lens formula, 1 by V naught minus 1 by U naught is equal to 1 by F naught. So 1.5 minus 1 by 2. 6. 4 minus 3. 1 by 6. So V naught is 6 centimeter. And we know VE. VE is minus 25 centimeter. So we can find UE. So 1 by UE is equal to 1 by FE minus 1 by VE. 6.25 minus minus plus. LCM is 625. 100 plus 25. 125 upon 625. UE is 5 centimeter and V naught is 6 centimeter. So this tube length or distance between two lenses is 11 centimeter. Option D. Question number 2. The refractive index of prism is under root 2. Mu is under root 2. If the angle of prism is 60 degree, at what angle a ray must be incident on it so that it suffers minimum deviation? For minimum deviation, R is A by 2, that is 30 degree. And from Snell's law, sin I is equal to mu sin R. Sin I is equal to root 2. Sin R is sin 30. Sin 30, 1 by 2. This is 1 by root 2. So I is 45 degree. Option B. Question number 3. The focal length of a convex lens is 20 centimeter. An object is placed at a distance 30 centimeter from its focal point. So U is actually 30 plus 20, 50 centimeter. The ratio of the size of the real image to the object means magnification, and for lens magnification is f upon f plus u. Focal length is 20, this is minus 50, 20 by minus 30. So ratio is 2 by 3, magnitude is 2 by 3. Option A. Question number 4. Light is incident normally on face AB. Prism, right angle prism is given. This angle is 90 degree. This is 30 and this is 60. A, B and C. Light is incident normally on face AB. So like this angle is 90 degree. And here some liquid is given. Refractive index of prism is 3 by 2. The limit of mu for which total internal reflection takes place at the face AC. Here at face AC, TIR is happening. And the effective index of this liquid is mu. So we know sine IC is equal to 1 by mu prism with respect to liquid. Means mu prism and this is mu liquid. And this angle is 90, this is 60. So this angle is 30 and this incidence angle is 60. Sine 60 is equal to mu lens upon mu prism, which is 3 by 2. This is root 3 by 2, 2 and 3. This is mu lens, 3 root 3 by 4. For TIR, this should be this mu prism with respect to lens. This IC should be greater than this incidence angle should be greater than the 60 degree. For that, this should be mu should be small compared to this prism. So lens mu lens should be less than 3 root 3 by 4. Option C. Question number 5. A concave lens forms the image of an object such that the distance between the object and image is 10 centimeter and the magnification produced is 1 by 4. The focal length of the lens will be. So we have a concave lens. Concave lens means it will works like a convex mirror. In convex mirror, image is always virtual होगी and small होगी. ऑब्जेक्ट यहाँ होगा तो इमेज यहाँ कहीं होगी and this distance is 10 centimeter. Magnification m is 1 by 4 positive focal length. So this is u and this is v. And magnification for lens is v by u. So v is u by 4 and 1 by v minus 1 by u is equal to 1 by f. Both are in same direction. So v is u by 4. So 4 by u. Okay, this is u minus v. U minus u minus v distance wise is 10 and this v is u by 4 or we can say u is 4v. 4v minus v is equal to 10. So 3v is 10. V is 10 by 3 and u is 40 by 3. So this is minus 3 by 10 minus plus 3 by 40 is equal to 1 by f. F is 40 divided by minus 9. This is equal to 4.4 centimeter. Option D. Question number 6. A concave mirror of focal length f in vacuum is placed in a medium of refractive index 2. Its focal length in the medium will remain same. Focal length of mirror does not depend on outside medium. Option B. Question number 7. A boy of height 1.5 meter and with his eye level at 1.4 meter stand before a plane mirror of length 0.75 meter fixed on the wall. The height of the lower edge of the mirror above the floor is 0.8 meter. Then this is the boy, this is his eye. Total height is 1.5 meter and eye level is at 1.4 meter. Mirror length is 0.75 meter. The height of the lower edge of the mirror. Lower edge of the mirror is at 0.8 meter and the size is 0.75 meter. Yes. To see his feet, position of lower end कहाँ पे होना चाहिए 1.4 divided by 2.7 meter, but this is more than 0.7 meter, so he can't see his feet. And to see his eyes, see his head, the upper end, this is 0.8 and this is 0.75. So after adding these two, this upper end position is 1.55 meter, which is more than his height of head. So he can see his head, but he can't see his feet. Option C, the boy cannot see his feet. Question number 8. A horizontal ray of light passes through a prism of refractive index 1.5 whose apex angle A is 4 degree, small angle prism, and then strike a vertical mirror M as shown. For the ray after reflection to become horizontal, the mirror must be rotated through an angle of. So to make this final reflected ray horizontal, total deviation should be 180 degree. And we can find this deviation, delta 1. Delta 1 is mu minus 1 into a for small angle. We use this formula. This is 1 by 2 into 4, 2 degree. This angle is 2 degree. This is also 2 degree. This is 2 degree. So if we rotate this mirror by 1 degree, this reflected ray will turn by 2 degree. It becomes horizontal. So, or we can say if we rotate this mirror 1 degree, then new normal is in this direction. So angle of incidence is 1 degree and angle of reflection is also 1 degree. Finally, it becomes horizontal. So option A, angle of rotation of mirror is 1 degree. Question number 9. An object is placed at A. OA is greater than F, where F is the focal length of the lens. The image is formed at B. A perpendicular is erected at O and C is chosen such that BCA is 90 degree. Then the way F in terms of A, B, C. This is the lens, a convex lens. This is A, C, and B, and this angle BCA is 90 degree. This length is C, this is A, this is B. So we know U and V. So focal length formula, this is 1 by 4 length is equal to 1 by F. V is positive, this is U is negative, minus minus plus is equal to 1 by F. So F is equal to AB upon A plus B. But this type of option is not given. So from here this is C and this is A. So this side becomes, this is under root A square plus C square, and this becomes under root B square plus C square, and this becomes hypotenuse for this new triangle ABC. So A plus B ka whole square is equal to A square plus C square plus B square plus C square. A square plus B square plus 2AB is equal to A square plus B square plus 2C square. From here, AB is equal to C square. So F is C square by A plus B. Option C. Question number 10. An object is moving towards a concave mirror of focal length 24 centimeter. When it is at a distance of 60 centimeter, the mirror, from the mirror, its speed du by dt is 9 centimeter per second. The speed of its image at that instant. So first find V. We have U and F. So 1 by V. This is a mirror. 1 by V plus 1 by U. So this is equal to concave mirror. F is negative, minus 1 by 24 plus 1 by 60. LCM minus 5 plus 2 minus 3 upon 12 to 5 minus 1 by 40. V is equal to minus 40. And after differentiating this equation, we'll get 1 by V square dV by dt is equal to 1 by U square du by dt. So dV by dt, velocity of image is equal to minus V square by U square du by dt minus 40 square upon 60 square into 9. Four centimeter per second, and this object is moving towards. So image will move away from the mirror. Option C. 4 centimeter per second away from the mirror. A ray of light passes through an equilateral prism such that angle of emergence is equal to angle of incidence and is equal to 3 by 4th of the angle of prism. Means I is equal to E is equal to 3 by 4 times of A. The angle of deviation is this triangle, this prism is equilateral prism. So A is 60 degree. So 3 by 4 into 60 degree. This is 45 degree. And we know A plus delta is equal to I plus E. So delta is I plus E, 45 plus 45, 90 minus 60, 30 degree. Option D. 12. A plane mirror is placed at origin parallel to y-axis, facing the positive x-axis. A plane mirror is placed at origin parallel to y-axis, facing the positive x-axis. This is positive x-axis. An object starts from 2, 0, 0 with a velocity v object is 2I plus 2j. The relative velocity of image with respect to object. So this two actual velocity is in this direction. This is 2I and this is 2j. So image velocity parallel component will remain same and this normal component will be in opposite direction minus 2I. Now final relative velocity of image with respect to object. So these component cancel out with them and velocity of image with respect to object is minus 2I minus 2I minus 4I. Negative x-axis. It is in the direction of negative x-axis. Option C. Question number 13. A ray of light passes from vacuum into a medium of refractive index n if the angle of incidence is twice the angle of refraction, then the angle of incidence is. So from vacuum to a medium of refractive index n, and the angle of incidence is twice the angle of reflection. This angle is twice, so this is I by 2 actually. And from Snell's law, sin I is equal to n sin R. This is 2 sin I by 2 cos I by 2 and sin I by 2. Cos I by 2 is n by 2. I by 2 is cos inverse n by 2. Option C. 14. A point of source of light is placed Question number 14. A point of source of light is placed at the bottom of a vessel containing a liquid of refractive index 5 by 3. A person is viewing the source from above the surface. There is an opaque disc of radius 1 centimeter floating on the surface. The center of the disc lies vertically above the source. The liquid from the vessel is gradually drained out through a tape. The maximum height of the liquid, for which the source cannot be seen at all from the above. So this is the case of the TIR, total internal depth. Assume this is the size of the disk. This liquid refractive index is 5 by 3. The person is viewing the source from the above the surface. There is an opaque disc of radius. This is 1 centimeter. And we need this height. So for TIR, this is IC. This is also IC. Sin IC is 3 by 5, means 37 degree. IC is 37 degree. And we need this H. So tan IC is equal to 1 centimeter divided by H. And tan IC is 3 by 4. So H is 4 by 3. Option B. Question 15. Two plano-convex lens, each of focal length 10 centimeter, and refractive index 3 by 2 are placed as on water is filled in the space between the two lenses. The whole arrangement is in the air. The optical power of this system in diopter. So there are actually three lenses. Two plano convex and one this water lens is equiconcave. Focal length of each plano is 10 centimeter, and for plano this is equal to mu minus 1 by r. This is equal to 1 by 10. This is 3 by 2 minus 1 by 2. From here r is 5 centimeter. And net power is P1 plus P2 plus P3. This is 1 by F1, 1 by F2. This is concave, so minus 4 by 3 minus 1 into 2 by R. This is in centimeter. In diopter, multiply by 100 to 6.67 diopter. Option A. Question number 16. A ray incident at an angle of incidence 60 degree enters a glass sphere of refractive index root 3. This ray is reflected and refracted at the farther surface of the sphere. The angle between reflected and refracted ray at this surface. So we have a sphere of refractive index root 3 and a ray is incident at 60 degree. This angle is 60 degree. Then this will turn. This is 60 degree. And this is reflected. This angle and this angle are same. So first find these are. So sine 60, that is root 3 by 2, is root 3 times of sine r. So this is 30 degree. 30 degree. This is also 30 degree. This is 30 degree. This is 60 degree. So this angle is 90 degree. Angle between reflected and refracted ray at the farther surface is 90 degree. Option D. 17. A water film is formed on a glass block. A light ray is incident on water film from air at an angle 60 degree. What is the angle of incidence on the glass block? This is water film, this is glass, and it is incidenting at angle 60 degree. Then we need angle of incidence at the glass surface. What is the angle of incidence on glass block? So we can apply directly Snell law. This is 4 by 3. So sine 60, 4 by 3 into sine I2. This is root 3 by 2. So I2 is sine inverse 3 root 3 by 8. Option A. An object O is kept in air in front of a thin plano-convex lens of radius of curvature 10 cm. Its refractive index is this, and medium towards right of plane surface is water refractive index 4 by 3. What should be the distance x of this object so that the ray become parallel finally? This is 4 by 3 and this is 3 by 2. We need this distance x. Radius of curvature is 10 cm. So if we put this object at focal length of this plane of convex, it becomes parallel and the surface is plane. So there will be no deflection at this surface. So find focal length actually. X is focal length, and for plano convex focal length is mu minus 1 by r. This is 1 by 2 into, so focal length is 20 centimeter. So x is 20 centimeter. See 19. If the critical angle for the medium of a prism is C and the angle of prism is A, then there will be no emergence ray direct condition. When A is greater than 2C, there will be no emergence. Question number 20. Two media A and B of refractive index. In two media A and B of refractive indices mu1 and mu2 are separated by xz plane. Light travels from A. Here, this medium is A, this is B. Refractive index is 2. The incident ray, a ray of light travels from A to B. The incident ray and the reflected ray are represented by unit vector. The incident ray and the reflected ray are represented by unit vector, this and this. Then this is incident ray and this is reflected ray. This is I and this is R. So we know this normal, this is J cap. So incident direction D1 cap cross normal direction into refractive index N1 is equal to N2 direction of reflected cross normal direction. Snell law is actually n1 sine I is equal to n2 sine R, and sine theta we will get from cross product of two vectors. So we know incident direction and normal direction. We can find this I and R. N1 is 3 by 2. This is D1 cross. Okay, this incident vector is actually unit vector, which is AI plus BJ. This is cross J, normal is in Z direction, is equal to N2. Reflected is CI plus DJ cross J. And this N2 is 2. Now this is 3 by 2 IJK. This is AK. JJ 0 is equal to 2 IJK CKK. This is 0 KK there. So A by C is equal to 4 by 3. Option B. Question number 21. A thin prism of angle 6 degree and refractive index for yellow light is 1.5 is combined with another prism of angle 5 degree and NY is 1.55. The combination produce no dispersion. The net average deviation produced by the combination is 1 by x. The value of x is, so we know net delta is delta 1 minus delta 2. Delta 1 is mu 1 minus 1 into A1 minus mu 2 minus 1 into A2. For first minus, this is 0.5 and 65 into 5 degree. This is equal to 1 by x. This is 3 degree minus, so 0.25, or we can say 1 by 4. So x is actually 4. 22. The radius of curvature of each surface of a convex lens. The radius of curvature of each surface of a convex lens having refractive index n is 1.8 and r is 20. The lens is now immersed in a liquid of refractive index and liquid. This is n lens. This is medium. Is 1.5. The ratio of power of lens in air to its power in the liquid. So in air, power is 1.8 minus 1 into 2 by r. This is in air upon liquid or medium is equal to n lens upon n medium minus 1 into 2 by r. 0.8 divided by 3 by 15. 4. This is x ratio 1 is 4, so x is 4. 23. In an experiment to measure the focal length of a convex lens, the magnitude of object distance x and image distance. This y is image distance and this is object distance with reference to the focal point of the lens. The y-x plot is shown in figure. The focal length of the lens is, so this is actually this A, B, C, D, E is the graph between U and V, and we know coordinate of this point. At this point, U and V we have 2020. So 1 by F is equal to 1 by V minus 1 by U. V is 1 by 20. In an experiment to measure the focal length of a convex lens, the magnitude of object distance and image distance are measured with reference to the focal point of the focal point of the lens. So distances are given from the focal point. So Newton formula, we will apply Newton formula x1 x2 under root 20 into 20. F is 20 centimeter. Question number 24. A light ray is incident on a glass slab of thickness 4 root 3 centimeter and refractive index is root 2. The angle of incidence is equal to the critical angle for the glass slab with air. So incidence angle is actually IC. I is IC. And IC is sine inverse 1 by n. This is 45 degree. Lateral displacement of ray after passing through the glass slab. This is 60 degree. No, incidence angle is 45 degree. This is R. This is I minus R. This lateral, we need this lateral displacement, L. This is T. This is T by cos R. And L is T by cos R sine I minus R. T is 4 root 3 on cos R. Okay, first find this R. From Snell law, sine 45 degree is equal to root 2 sine R. So R is 30 degree. And this is 15 degree. Cos 30 sine 15. This is lateral displacement. L is 4 root 3. Cos 30 is root 3 by 2. And sine 15 given equation 0.25 or 1 by 4. This is equal to 2 centimeter. 25. A container contains a liquid with refractive index of 1.2 up to a height 60 centimeter, and another liquid having refractive index 1.6 is added to a height h above first liquid. We have a container. First liquid is up to a height 60 centimeter. Refractive index is 1.2. And second liquid is of height h above first and refractive index is 1.6. Viewed from the above, the apparent shift in the position of the bottom of the container. So apparent shift delta x is 40 centimeter. The value of h. So net apparent shift is equal to T1 minus T1 by mu1 plus T2 minus T2 by mu2. This is 60 minus 60 upon 1.2 plus h minus h upon 1.6 is equal to 40. This is 10, 30, h 1 minus 10 by 16, 6 by 16. H is 80 centimeter. 26. A converging beam of ray is incident on a diverging lens. Diverging lens means concave lens. And a converging beam. After passing through the lens, the ray intersect at a point 15 centimeter from the lens. If lens is removed, the point where the rays meet moves 5 centimeter closer. So this distance is actually 10 centimeter. Find the focal length of the lens. So if we put object here, final image will be here at 10 centimeter. So 1 by V minus 1 by U is equal to 1 by F. V is minus 10 and U is 15. F is 30. 27. A parallel paraxial beam of light is incident on a glass sphere of radius 10 centimeter along its diameter AB from one side as shown. If all the rays are after refraction converges at point B, then calculate the refractive index of the glass sphere. Incident rays are parallel. This radius is 10 centimeter and these rays are converging at point B. And we need this n refractive index. So we know U is infinity and V is 20 centimeter. So from spherical surface formula is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. U is infinity, mu2 is mu, V is 20. This is mu minus 1 upon R is 10. Mu is equal to 2. 28. Two plane mirrors are inclined at 70 degree. Plane mirrors are inclined at 70 degree. Theta is 70 degree. A ray incident, okay, this angle is 70 degree. A ray incident on one mirror at angle theta. After reflection, falls on the second mirror and is reflected from there parallel to the first mirror. Then theta is. After reflection from second mirror, it is moving parallel to the first mirror. This is mirror 1 and this is mirror 2. So this is 70 means this is also 70. And this is 70, so 70, 70, 71, 40. This is 40, so theta is 50 degree. 29. An object is placed in front of a convex mirror at a distance 50 centimeter. A plane mirror is introduced, covering the lower half of the convex mirror. This is the convex mirror. This is object at 50 centimeter, and lower half is covered by a plane mirror. If the distance between the object and plane mirror is 30 centimeter, it is actually here. This is 30 centimeter. There is no parallax between the image formed by the two mirrors. So if this distance is 30 centimeter, image distance from this plane mirror is also 30 centimeter. And this total distance becomes 60 between object and image. And image formed by this convex mirror should also be at the same position. So this distance is 10 centimeter. We know u and v. We can find f. 1 by v, 1 by u is equal to 1 by f. This is mirror, so this u is negative. F is 50 by 4. Radius of curvature is 2f. 100 by 4. This is 25 centimeter. A point object is placed at a distance of 25 centimeter from a convex lens. U is 25. Focal length is 20. When a glass slab of thickness T and refractive index 1.5 is inserted between the lens and the object, the image is formed at infinity. Lens is convex lens actually. And this distance is 25 centimeter. So initially this f is 20 centimeter. If we put object at 20 centimeter, final image be at infinity. But actually it is at 25 centimeter. So we will put a glass slab of thickness T and refractive index this 1.5. So there will be a normal shift. So if this shift is 5 centimeter equal to 5 centimeter, this apparent distance becomes 20 and final image will becomes at infinity. So we know apparent displacement delta x is equal to 5 centimeter is equal to t minus t by mu, or we can say this. This is equal to 1 minus 2 by 3. 1 by 3 is t is equal to 15 centimeter. 31. Inside a solid glass sphere of radius r, a point source of light is embedded at a distance x which is less than r from the center of the sphere. The solid sphere is surrounded by air of refractive index One, the maximum angle of incidence for rays incident on the spherical glass air interface directly from the point source is point source is here actually. This is the center and this is the normal. The maximum angle of incidence for rays incident on the spherical glass air interface directly from point source. This is angle of incidence. And this distance is x. This is r. Assume this angle is theta and apply sine law. Sine I by x is equal to sine theta by r. These are constant. If this theta is maximum, I will be maximum. And theta, Yes. Oh. Okay, this will be maximum, and this is maximum, and maximum value of sine theta is 1. So sine I, maximum value of sine I is x by r. So maximum value of I is sine inverse x by r. Option B. Question number 32. A small rod ABC is put in water making an angle 6 degree with vertical. If it is viewed paraxially from above, it will look like bent shaft ABC dash. The angle of bending CBC dash will be in degree. This is 6 degree. This is A, this is B. We need CBC dash, this angle, theta. So if this is 60 degree, this is also 60 degree. This is H, this is H by mu. For small angle, tan theta is theta. So 6 degree is equal to x by h. And 6 plus theta is x upon h by mu. Mu is 4 by 3. Theta is 2 degree.